Hello again, ACST1052 students. This is Doug Fletcher with another video looking at some of the finer points of dynamic arrays in Excel. Now, in one of the earlier videos, we already looked at creating financial functions, and so we can create our sequence of values here, and we might use the maximum term to control how many rows we want in the sequence. And then you might think, well, we're going to want an accumulation function here, so we do 1 plus the interest rate to the power of whatever number appears in the first column, and take the whole array, and there we go, and that's going to respond to changing of interest rates, and that should all work fine. And it does to a point, okay? But something to bear in mind when you're doing things like accumulation functions, especially when the models get large, and this one's really quite small, is what's the most efficient way to do this? Now, what we're doing here is we're taking 1.04 and we're raising it to a power. And we're doing that separately in every single cell down here. Now, admittedly, we're doing it relatively efficiently because we've got all that in one formula up here, and that one formula fills all those cells. So that's quite nice. But in fact, we'll be doing it more efficiently if we can simply do this. And I'm going to lay this out in some steps. So what we could do is we could take a whole array filled with 1.04. So we could have a sequence, we could have the number of rows that's set up there, we're going to have one column, we're going to start at 1 plus the interest rate, and the step value will be 0. So that's just going to fill that with 1.04. And then what we'd really like to do is to do a little accumulation. So we take this one, let's take the first one to be equal to the top one there, and then take the next one to be that one times the one next to it, and so on. And if we did that, then we'd get an accumulation. Now, this is being generated by a series of 9 minus 1 equals 8 multiplications. So we've got 8 multiplications rather than 9 exponentiations here, 9 times raising to a power. So this is actually a more efficient calculation. Again, I emphasize that when you've only got 9 rows in a table, it makes practically no difference. But if you have a big model, then thinking about things a bit more efficiently is a good thing to do. Now, what we'd like to know is there a way where we can get Excel to do this cumulative product? All right, so successive products through an array. And there is actually a way to do this. And this is called the scan function. So once we have all our factors in there, and we're going to use the same factor because we're just accumulating at a fixed interest rate, the Excel function that we need is called scan. Now, what you do with a scan is you take some initial value. Now, you could be scanning doing multiplication, which is what we're doing here. And in that case, the initial value will usually be 1. That's what we're going to use. So we're going to start from 1. And then as we work our way through the array, which is the next argument, and we've already calculated that with our sequence. As we work our way through, we're going to take the first value in the array times the initial value. So the first value in the array won't be changed. And then we store that result back into the initial value. And then we multiply that accumulated multiplication, multiply that by the second element in the array, and so on. And so we work our way through multiplying successive elements and storing those results at each point. And the way we define this is using a general, what they call an anonymous function called LAMBDA. Now, LAMBDA has been taken over from some computer science concepts called an anonymous function. So LAMBDA is what you use when you're inventing a function and you're not really giving it a name. Right, so LAMBDA stands for an anonymous function. And what it does is it's extremely general. Sorry, I need to open a bracket there, and there'll be a close bracket after that as well. So when we use LAMBDA in the context of a scan, then there are two parameters that go in here. The first one is an accumulator. So this stores the successive intermediate results. And the second parameter is a value from the array. So those are the two parameters, A for accumulator, V for value from the array. And then we define the calculation, and we're going to do a product. Right, so at each step, we're going to do A times V and store that result in A. But that result will also be put into the array itself. All right, and then because it's stored in A, it gets carried on to the next value. All right, so let's see what this does. And here we have our accumulation, just like in the original column there. Now, because this other column was depending on that one, it's now got strange results in it. So I'm going to delete that. And so that's what the scan does. It does a single calculation repeatedly through an array and stores the intermediate results in the elements of that array. And so we've got our 9 multiplications done in there, and that's a more efficient way of generating a list of successive multiplications. So the scan function is extremely useful. Used for products, it can also be used for sums as well, which is another application. Okay, so bear that in mind. It's quite a useful thing. So if you need a whole string of successive products, cumulative products, you can define a set of constants using the sequence with a step of 0, and you scan through using a LAMBDA function that has a product in it. Okay, that's all for this array, for this video.